So now we get to the method of elimination, right? Which you're going to see that the math in the end ends up being pretty close to the same thing. But it's a slightly different method, elimination. So the objectives, these are all the same things as we had up there the other day. I just underlined. Today we're going to do elimination, which gives us, that's our third way to solve a system. Graphing, substitution, elimination. There's actually one other, I would say. Matrices. But we don't do that. Yeah, the plural of a matrix is called matrices. Yeah. It's something you can do in a calculator that's pretty slick, and it goes really, really, really quickly. I like doing that, but it's not in our curriculum anymore because they know better. Okay. So review these concepts. A system of equations is more than one equation with more than one variable. Right? This is just reviewing what we've already just said. In a linear system of two equations and two variables, the solution is the point, x, y, where the lines intersect. And we have these methods now for solving. We've already gone over graphing and substitution. We're actually going to take the next 2 days to do elimination. Okay, here's the steps for elimination. So I put in a step 0 because before you can even get started, you've got to have the equations in standard form. We know what that means. With the x's lined up and the y's lined up, right? X's on top of x's, y's on top of y's. That's always the starting point for elimination. So you wouldn't go to the next step until you've got both equations in standard form. Now, step 1, we're not even doing that one today. We're going to do that next class because that's the way it's presented, and it's not bad. That means our lesson's shorter today, and we can review a little bit before we take a quiz. Step 2 is we are going to add or subtract the two equations with each other, and it will eliminate one of the variables. That's why it's called elimination. Remember, in substitution, when we solved for one variable and then we plugged it into the other, we eliminated a variable. Okay, well, that's what we're doing here. Just doing it in a slightly different way. And, you know, you get an answer for one variable by doing that second step. And then you're going to have to plug it in to find the other variable. Now, unlike substitution, where you have this perfect place to put the first answer, because the equation you solved for one variable, here you don't. Here you got to go up to one of the original equations, and you can choose which one and solve for the other variable. Exactly 30 seconds. You good? Hurry. So, are these equations both in standard form with the variables lined up? Sure. I mean, most of the time, we're not really trying to trick you there. Most of the time, if it's not in standard form, then you don't use elimination. You probably use substitution to solve it. Right? Like if one of them is in y equals mx plus b form, then it's already solved for one variable. So why use elimination? Just use substitution. So most of the time, it will be all lined up like this. Now, we're not doing the first step here. In the first step, which we practice next class, then you look at your system and you see that if you added up the equations, it wouldn't eliminate a variable. So you end up having to multiply one or both of the equations so that they would. Here, you could see that if you add the equations right now, if you add the x's, it cancels the x's. So in one step, we're going to get rid of one variable. So when you add two equations like that, you're going to get a combination of the two that then you solve. So at this point, you can see since 2x is the opposite of negative 2x, add them up. That's the step 2. Right? But like I say, you would never move to step 2 if it wasn't in that situation. And next class we'll figure out, okay, well then, how do we do that? That's wrong. I think that's right. So add up the 2x plus negative 2x, they cancel. 3y plus 5y. (11 plus 13). Right. So you add them up to eliminate a variable, and then you solve what's left. Right. In this case, y equals 3. Right. So that's just one of the coordinates. Right. We need the other one, and again, we don't have the place like we did in the substitution where we always go. You're going to go back to one of these first two equations. It doesn't matter. You pick which one you think would be easiest to substitute the y equals 3 for and solve. Does anybody have an opinion there? Which one of these two would be the easiest to take that 3 and put it in? Why the first one? Yeah, I mean, I'm thinking the same. I don't like having negatives. If I can avoid it, I'm probably going to go with that one. So let me plug in this way. Okay. If you do the other one, you're still going to get it right. Okay, it doesn't mean you can get it wrong because you chose the wrong equation to substitute for. 2x plus 3 times 3 equals 11. So 2x plus 9 equals 11. So now we have an equation, one variable, solve. 2x equals 2, x equals 1. So what is the solution? 1, 3. Right? X, y. Seems easy enough, right? Good, Bree? You okay? Okay, so let's try. This is not a U try. No, it is a U try. Do the same thing with that. Quiet, please. Quiet. So remember, when you're looking at the system, right, and it's in standard form and the variables are lined up, you want to get to a step now where you eliminate a variable. When that's a negative and that's a plus, you can, by adding the two equations, you're going to cancel the y. That means you add these and you add these, right? So whatever you're doing to cancel that variable, you got to do the same thing with the other terms too, right? So in this problem, if I add them up, these cancel and I get a 0. 2x plus 0 equals negative 2. So 2x equals negative 2, x equals negative 1. Okay, then you got to pick one of these two to plug that in and solve. I'm going to do this one. Why this one instead of that one? Didn't we say something about the negatives? True. Yeah, I can see that negative 2 times negative 1 is going to give me a positive anyways. So then in the end, does it really matter? It doesn't really matter. So let me go this way. Go this way for the second one. Negative 2 times negative 1 plus 3y equals negative 7. So that's 2 plus 3y equals negative 7. Subtract 2. 3y equals negative 9. Divide by 3. Negative 3. So there's your answer. Negative 1, negative 3. Okay. Prossimo. Okay, now, if I add these two, will it cancel a variable? So any suggestions? Or? Kate, what you doing? Pay attention? Yeah. Subtract them, right? If they're actually not opposite, then just subtract, right? If I subtract 3y minus 3y, it will cancel the y's. But then I have to subtract here and here. Okay. You could multiply by negative 1 and then add them up. That would work too. It's essentially the same thing, right? Subtracting is adding a negative. So it's really doing the same thing. Honestly, if I'm solving these things, though, I wouldn't take that step and multiply by negative. I just subtract. And I would probably subtract in a way, like I could choose. I could subtract this equation minus this equation. That'll give me 4x minus 5x is negative x, right? Or I could do it the opposite. I could do 5x minus 4x and get a positive x. I just have to be consistent, right? So if I do this minus this, this minus this, this minus this. So you subtract in some order or another. I'm going to just do it like it's set up already, right? I'm going to go like this. I'm going to go minus and subtract. 4x minus 5x is negative x. Plus 3y makes plus, or 3y minus 3y makes 0. 2 minus negative 2, 4. Right, so negative x equals 4, x equals negative 4. And then pick some place to solve for the other. How about I'll go to the first one? Right, I'll go 4 times negative 4 plus 3y equals 2. Negative 16 plus 3y equals 2. Add 16. 3y equals 18. So y equals 6. So the answer is negative 4, 6. Yeah, see, the only thing about the multiplying by a negative, it's kind of what we introduced next class, which is what if they're not exactly like you want them? Multiply by one or the other by something. So we're really not getting to that step yet. But if you've seen this before, and so that's what you do, it's okay. Just get it right. That is the bottom line. Get it right. So try this one. You try. Yeah, you're right. I was looking at that going, what the heck did I do there? All right, so it should have been a 1-1. Uno, uno. Okay. So can we solve this one by elimination? Can we move on to the next step? No. We can't because they're not in standard form. That's why we had the last unit, some of the questions were, put this thing in standard form. Right? The first one's in standard form. How do I make the second one in standard form? Yeah, I need to get the x term over here. So let's just subtract 3x from both sides. Okay? So the new system of equations will look like okay, so now, can I add or subtract these and eliminate a variable? Which variable is going to get eliminated here? It looks like the y would get eliminated if I did what? Plus, right? It looks, these are opposites, so you definitely want to add, right, to cancel. So this is 5x plus 0 equals 10. 5x equals 10. X equals 2. So how about I'll come up to, it doesn't matter, I think I'll go here. 4y equals 3 times 2 plus 14. 4y equals 6 plus 14. So if they're not in standard form, put them in standard form. Yeah, and make sure, you put them in standard form and the x's up right on top of each other, the y's right on top of each other. Okay. So it's probably a U try here. So do the same thing. I heard one right answer. Incorrect. 1, 2. 1, comma 2. So first, right? You had to move the 4x to this side, so it's negative 4x. Did you have negative 4x plus 5y is 6? So we all start at that point. Because these are the same, we subtract. So 2x minus negative 4x is positive 6x, right? Minus a negative, Hayden, you should get a graphing calculator, right? Put phones away. Oh, okay. So that should have been a positive 6x. These should have canceled, and 12 minus 6 is 6. So if you made a mistake in there, okay. Divide by 6, and you get 1. And then you plug that back in. I plugged it in here. 5 times y equals 4 times 1 plus 6. Y equals 2. We good? Okay. Okay. During a kayaking trip, does anybody kayak around here? I like it. Kayaking. Okay, quiet please. The longer it takes, the less time in your quiz. Okay. During a kayaking trip, a kayaker travels 12 miles upstream against the current and 12 miles downstream with the current. Find the speed of the kayak and the speed of the current. So basically, when he's going in one direction, whatever effort he's putting into it, or she, the current is like pushing him to go faster. But then in the other direction, it's kind of working against him to make him go slower. Yeah. I gotta see, did I miss a piece of data in this? Yeah, you know what? I may have missed something from the graphic. Which? Oh, yeah. Sorry. Good point. Okay, so when he's going against the current, it took him 3 hours. When he's going with the current, it took him 2 hours. Thank you. So what's the speed if you go 12 miles in 3 hours? "12 miles in 3 hours is 4 miles per hour, right? And then on this one, this is the S2. We've got 12 miles over 2 hours is 6 miles per hour. So what we know is that if we add the two, right, x plus y, when they're working together, those two speeds, it equals 6. He's going faster. When he's working against the current, then he's going slower. So there's a system of equations that we just should be able to solve. Right? So first we had to calculate the speeds. The net speed, when you put the two together, is faster. It's faster when he's going with the current, and it's slower when he's going against. They're working against. They have opposite signs. So how do I solve that? Using what we've already been doing in class today? Elimination, right? And you could either add or subtract at this point, right? Because if you add, you're going to cancel the y's. If you subtract, you're going to cancel the x's. But let's add. Usually you would add. So you get 2x equals 10. So x equals 5. Okay. And the other, I got to plug that back in here. It'll be 5 plus y. 5 plus y equals 6. So y equals 1. So, well, in this case, it's not a point, is it? It's two different speeds. The context of the problem is, what's the speed of the guy and what's the speed of the current? And it looks like he's going 5, and when he's got the current at his back, it adds together to give him 6 miles per hour. When it's like going into the face of the current, then he's getting 4. I mean, no, I guess not. Now, I'm not going to work through these. And I'm just going to say that if you get a problem which has got fractions in it, what could you do?
Get rid of it.
You can always multiply through to get rid of denominators, right? So you didn't have that to deal with. Now, if I was going to do that in this problem, then I would probably multiply the top equation by 2 because it would cancel the 2, but I would have to multiply the bottom by 4, so it cancels this, right? It makes that just x, but it'll make that minus 2y. If I do that, now they're not opposites anymore, or they're not the same. So it's almost like this is more like something that we would do once we get to the next lesson, when we actually do multiply by different things. But I mean, there's nothing that would stop you from subtracting this. right? Because these are they're equal. You could just say 8x minus 1/4 x, and that'd be 7 3/4 x. Cancel. Yeah. So you could either multiply by a constant, something to get rid of your denominators, or just add or subtract as they are, since it does look like these two, right, would cancel. This would become 7 3/4 x. This would become negative 31, which is a mess, but 28, actually it's 31/4 times x equals negative 31. And the same thing with decimals, right? You could multiply by something to move the decimal place over 1. If you do, you might lose that equal or opposite coefficients that we kind of depend on for what we're doing so far. I mean, it looks like here that if I put these into standard form, that these here are either going to be the same or they're going to be opposites. So we would probably, we don't want to mess with that. I don't think we actually would in this, because what would I multiply the first one by to get rid of the decimal point? Since it's tenths, you would multiply by 10. And what about the second one? 10. So you could do that, and this would be 17 and 17, so they're still going to cancel. So that is, I could have gone like this. And that would have given us 40 minus 48x equals 17y. 128 plus 17y equals negative 132y. Oh, I think one of these is supposed to have been an x. Okay. So that's the end of that. So we only have one more lesson of this stuff, and that is, I think, 1819 must be 2. But we got to do one more day on elimination. The one more day will be what happens if they don't have equal or opposite coefficients. So write down that.